Hello everyone, my name is Stefan Junesco Frestian, and for now I would like to present about our research. The title was Indoor Air Quality Monitoring System using Node.js and MQTT Application. And first thing, let me share screen to you all. Okay, and the first was the content, and the content in this presentation was abstract, introduction, objectives, related works, method, and design system, implementation, result, and conclusion. Okay, the first thing, what is IIQ? IIQ was indoor air quality. But first, as we know, air pollution is always a problem that continues to grow every time. Not only affects the environment, air pollution also affects human health, so it needs to be dealt with quickly. Air quality in environment, especially indoor area, becomes something that is rarely considered, even though we spend more time indoors. So it's also important to know the air we breathe. The development of information system makes it easy to build a monitoring system that can be integrated with efficient data and more affordable device. Based on guidelines regarding IIQ in the school, there are several methodologies recommended by World Health Organization, such as conducting air quality and then monitoring in the classroom, and then measuring and inspecting ventilation ducts, and then evaluating humidity, temperature, and more, as well as surveying buildings and school residents. So that is expected by 2020, child care facilities, kindergartens, and schools and public implementing World Health Organization's IIQ guidance. Okay, this is the objective from our research. The first thing was to investigate IIQ monitoring system and collect data efficiently from heterogeneous sensing IoT devices at sampling area. And the second, to analyze and monitor indoor air quality and develop an IIQ monitoring system using IoT platform with affordable price device. And the third was to provide information on indoor air quality through web-based application platforms with MQTT and Node.js. And then this is our previous research. The previous research on air quality also created in so many studies. As we can see, our reference was to 2018 and 2019, so it is the current issues. The research method that we use is SDLC, software development lifecycle. It starts with planning or study, and then defining, and then designing of system. After that, building prototype, testing systems, and then the last was application. In this research, a prototype device of a monitoring system for IIQ using the WSN or wireless sensor network. Use also Mission telemetry transport, or we call MQTT protocol, and Node.js is proposed. The study uses node sensor that can measure the environment, then sending data sensor to the cloud. And this is the hardware configuration. And then this is the illustration of our proposed method. So as you can see, the study uses node sensors that can measure the environment that sending data sensor to the cloud. Okay. In these studies, we have developed system with wireless sensor networks, IoT, and built a dashboard to visualize data using Node.js and web-based application, and should have made monitoring more efficient. The monitoring system is applied to retrieve the parameter data from the environment using the sensor node. And then the data is transferred to the cloud by using Wi-Fi or Ethernet network, so users can monitor efficiently. As you can see on the screen, this is the illustration of our prototype and our interface. Okay, this is the table of the comparison of the actual reading of the MK135. So we use three MK135 sensors were used in this study. And then the first thing was the calibration is done by determining the value of R0, which can be displayed with the program on a serial monitor. For the calibration pH3 sensor, the average error of the three MQ135 sensors used was 4%, and the reading did not reach 5%, but almost close. Based on the three sensors tested, it has almost the same percentage error value. It indicates the performance of each sensor is almost the same. And then this is the comparison of the actual readings of the THT11. For the temperature and humidity sensor calibration, the data on the thermometer is recorded manually and compared with the THT11 sensor output data. The average test results and the average error value from the measurement results obtained are in table 2. And then this is the last table. This table shows that we use the pre-data sensor, and this is the average sensor data for three experiments from three sensor nodes. So experiments were also carried out with the calibration procedure of the three sensor nodes by running it and testing it simultaneously. In the experiments, the sensors are programmed with the same algorithm and turned on almost simultaneously and placed in the same room. The experiment for the system is to turn on the three sensor nodes and record the data. The data generated is then on average and compared to fellow sensor nodes. The difference also shows the ability of each sensor of the same type, not necessarily having the same reading results, even though the same manufacturing process and program are given. And then this is the conclusion of our research. In these studies, an IRQ monitoring system using a low-cost sensor, MCU ESP8266, data communication using MQTT and Node.js, client libraries for the MQTT protocol, written in JavaScript, was successfully designed and implemented. Low-cost sensors used in the system have been tested directly and calibrated according to the dataset, and compare the results of direct testing with theoretical calculations in accordance with the corresponding datasets, right, and factory specifications, as well as with previous research available. Then to validate the program use and test the validity of the sensor data obtained. For the implementation of Internet of Things or IoT, MQTT protocol becomes one of the data transmissions solution. Sensor data published through MQTT broker and broker can be requested using the program on Node.js library. Sensor data can also be posted and linked to the database. Therefore, Node.js can be combined with MQTT to create an efficient real-time system. Wireless sensor network making the data transmission process to be fast and accurate while there is an internet connection. And the application of IoT to monitor environmental conditions in the right thing to do and continue to develop. And this is our recommendation. So the recommendation was for system recommendation can be further developed using fuzzy logic or with a combination of artificial intelligence to directly recognize air quality conditions. The system can also be developed in the form of an Android application and also adds augmented reality for a more interesting system visualization. I think that's all from me. Thank you very much and see you next time.